Hi there. Today we're going to be using the t distribution instead of the z distribution to be able to find the confidence interval for this set of data here. What I have here is that the data is such that the mean of x, the sample mean of x is 13.2, and the standard deviation of x, the variance of x is 18. Now, we must also be taking into consideration the value of n, which has been given in the question as 8. Now, n is a very small sample. We use the t distribution when the sample is very small. So that's where we use the t distribution. That's when the sample is very small. Now, how are we going to go about and calculate the 90% confidence interval? It's good practice to always draw your normal distribution curve. Now, we're assuming, because we've been given the question that this set of data is coming from a normal distribution. So this is our normal distribution curve, and I'm going to look at 90% confidence interval. So 90% must be somewhere here. And so what we do basically is 1 minus 0.9, which is 90%, divided by 2. And then you take 1 minus that, and you should be able to get something like, let me see, 1 minus 0.9, and all of that divided by 2. 1 take away all of that. And we're looking at 0.95 for our value of the alpha, which is from the from the t distribution table. Now, for this value, we have a small sample, 8. So we need to also look at the number of degrees of freedom. So the number of degrees of freedom here we're looking for is, if the sample is 8, we take away 1 from the sample. Therefore, our t value is going to be t 0.95 as calculated here. And then you're looking at n minus 1, which is 8 minus 1. That's going to give you 7. And if you were to look at this from the t distribution table, you will see that the value is given there as 1.895. And now from here, we can easily calculate the 90% confidence interval. And the rest is like just the same as you've learned in your advanced level HSC mathematics there. So what we're going to do is we're going to try and calculate the 90% confidence interval, which is basically the mean of x, the sample mean of x here, 13.2, all right, plus or minus the t distribution, which is 1.895. So 1.895 multiplied by the square root of your standard deviation, all right, and the standard deviation is 18, so that's 18 divided by the sample size, which is 8. So if we were to do this on our calculator, we should be able to get so 1.895 multiplied by the square root of we just see square root of 18 over 8, and we're bound to get 2.8425. So this is 13.2 plus or minus 2.8425. And therefore, I'm going to have a plus and a minus. So when I add, I'm going to get my upper limit and then the lower limit. Okay, so of my confidence interval, of course. So the confidence interval is going to be equal to this value plus that, which leads to plus 13.2, and that's going to give us 16.0425. I can say maybe 16.04, right? So this is my upper value, 16.04, and my lower value or lower limit is going to be 13.2, simply minus 2.8425, and that's going to give us 10.3575. Basically, I might reduce this to 2 decimal places, so 10.36. So this is your 90% confidence interval for a small sample size of 8 coming from a normal distribution. And that's how you go about to calculate your confidence interval using a t-distribution. Again, I say the t-distribution is used when your sample size is very small. I hope that video has been of some help. Take care.